So here is a nice table showing some examples of how energy services can be implemented for adaptation benefits as well. We started some discussion on that. So here are some specific examples. So examples of climate impacts. So we'll have this in this left column. Droughts. Let's start with that, which is, with climate, global warming and climate change, you have increasing extreme rainfalls in many places, and also flash droughts and increasing droughts in many places. So key risks here include water shortage, water services disruption, degraded water quality, water shortage for agricultural use. Often there are also health implications. Energy services like desalination, water disruption, water distribution, pumping and transport, so trucks and bottles. Supply and distribution efficiencies, etc., can be served by energy services, as well as irrigation and pumping. This can play out in a kind of a moral hazard sort of way, where governments are subsidizing electricity for farmers, and they're using it for pumping water and depleting water and salinizing the soils and so on. So you have to be careful about where the limits are in terms of benefits versus unintended consequences. So talking about benefits, adaptation benefits include access to fresh water in coastal areas for desalination. So with water, it's always an issue of quantity, quality and access. So even if you have desalination, who gets the water and who has access to it, whether it's economic limitation or physical access limitation, those things matter as well when you think about equity and justice when you implement these projects. Water supply reliability for human and industrial use, reduction of waterborne diseases and water recycling. So I mentioned health, so degraded water quality goes into that, improving or reducing health impacts. Maintenance or increase of crop yield. So the drought may be dealt with by not losing crop yields, or maybe sometimes even increasing crop yields with these energy solutions or energy services for adaptation benefits. You of course have warming as the most common impact of global warming, even though if you look at India carefully, it has a trend of local cooling, and the same happens over some parts of the oceans as well. So you have in southeastern US, for example. So obviously you don't expect the entire globe to warm everywhere. Some parts will warm faster, like the Arctic, the Mediterranean, Western Asia, and some parts will warm slower, like Eastern Pacific, North Atlantic, and India, and so on and so forth. So impacts could be reduction in food production, increased food loss, degraded air quality, and so ozone and other things begin to confound with increased temperatures and dryness and dust as well. Fertilizer, water use, water irrigation and horticulture, aquaponics can be provided from energy services. Food storage and refrigeration, especially in terms of off-the-grid local services, energy services with local solar grid and so on for food storage and refrigeration, also works for insemination of cattle, storing vaccines, all sorts of things. Air filtration system, ventilators in hospital, etc. And benefits include crop yield increase, reduction in food loss, which is a big challenge. Waste is a big challenge as well. Reduction in respiratory diseases is a health benefit there. So looking at the adaptation benefits, this is for an illustrative purpose only. A climate adaptation option should take into consideration the variability of climate change impact that differs significantly depending on specific sectoral, geographical, and social context. So if you already have an issue of food loss, air quality, food production, etc., that have not necessarily been related to climate change, then of course these energy services are still benefiting those issues. But when you say adaptation, it should mean reducing vulnerability and risk of a sector like food or agriculture or health in the face of climate change. Okay, so that's a little definitional issue there. Going forward, increased vector-borne diseases can happen because of temperature and also rain and drought. Heat and cold waves, of course, increase in heat-related diseases. And energy services include operation of healthcare facilities, refrigeration, space cooling or heating, fans, heaters, water chillers, freezers, ice making plants, and so on. And these come with advantages in adaptation benefits in reduction in disease rate, morbidity and mortality, heat or cold fatality reduction in vulnerable populations, and alleviation of heat stress as well. Talking about natural disasters that include tropical storms and floods, the issues you are trying to deal with impacts mass casualty caused by disaster, increase in crime rate during disorder, which happens a lot. Even in a country like US, Katrina and other incidences have led to mass looting and shoplifting and so on. Communication services disruption, energy supply disruption. And what are the energy services going to do for you? Energy supply for medical services, energy supply for lighting service, television, radio, internet, telephone, emergency energy service for residential, commercial, and industrial buildings, with adaptation benefits in continued operation of medical service, improved safety, particularly for women and children, dissemination of information and communication to reduce the impact of disasters, energy recovery for disconnected facilities. So oftentimes floods and disasters can disconnect various neighborhoods and facilities, and they can be critical, sometimes like wastewater treatment. If you have that cut off and it's not functioning, then it will amplify the impact of disaster and floods very, very quickly, right? So moving forward, examples of trade-offs and synergies between adaptation and mitigation. We already implied this in approaches, strategies, energy services that serve both mitigation and adaptation, but these are the examples of trade-offs and synergies in a more schematic way. So this feeds into here with this arrow, so I just split it for fitting it into the slide. So you have adaptation here improving and low adaptation here. So you have vulnerability increasing in this direction and vulnerability decreasing in this direction. You have mitigation increasing in this direction, with emissions can be increased or emission can be reduced. So in trade-offs you have adaptive emissions, so air conditioning, cooling, expanded irrigation systems, desalination, which we already talked about. For example, if you run all of these on fossil fuel energy, that's an issue, so emissions will increase in this direction. And they can be unsustainable, increasing vulnerability, so coastal urban sprawls and permanent deforestations can happen. Whereas here, sustainable win-win situations that we mentioned can help water demand management, heat management from buildings, while also reducing emissions and helping mitigation. So here new vulnerabilities can emerge in terms of increasing vulnerability. So the trade-off here, monoculture plantations for biofuels. So biofuels are touted as one of the ways to mitigate emissions, but where will the land come from? Where will the water come from? There is this constant idea being proposed that degraded lands can be used for biofuels, but this has not been demonstrated at scale. And often biofuels are mentioned with carbon capture and sequestration, called BECS, bioenergy carbon capture sequestration, but again, we have to scale it up. It's not clear that's possible yet. Expanded reliance on hydropower can make you more vulnerable in terms of extreme events, droughts, and evaporative losses, and rainfall reductions, and so on. Okay, so those are trade-offs. This feeds into renewable energy technology, helping synergies between adaptation and mitigation. So we are just putting these together, the same things here, saying that we can build for synergy by focusing on sustainable practices and renewable energy technology that's going to serve adaptation, needs as well as help reduce emissions and meet the synergy needs. Okay, so let's leave this podcast here and come back and look at another table on renewable energy solutions for adaptation in the water sector. So specific sectoral examples will help, which we did a little bit before by looking at energy sector, health, and now we are looking we looked at health and food, and now we are looking at renewable energies as a way to also serve adaptation needs. Okay, we can think of those as co-benefits, or we can design renewable energies to synergistically serve mitigation as well, or have renewable systems focused on mitigation but be synergistic with adaptation needs. The examples we have used are very straightforward: serving water needs, agricultural needs, health needs. Of course, we'll come to transportation as well. So we'll look at the water sector in the next podcast. Okay.